So to use law of sines, we had to have corresponding sides and angles matching up. Law of cosines, we won't have that. So we can't make that proportion anymore. So we're going to have side triangles and side angle sides. So the angle is going to be included to solve for that other side. Now, I only need you to write down these two. So write down one here and then this one. You won't have to memorize them. You just need to know how to use them. Now, this one's solving for a side length. Remember, sides are notated as the lowercase. And then this would be solving for an angle, all right, notated by the uppercase. So go ahead and write those down. So then we're going to use them. On this first one, we're going to have to find all the other angles. We're going to have to solve the rest of this triangle. And so I have sides of 8, 14, and 19. Now, you might want to take a little side note. If you're going to use law of cosines, go with the biggest angle first. It's gonna make your life a little bit easier. So you don't have any of those hidden donkeys, remember, those ambiguous cases. So if you're going to use law of cosines, use the biggest angle. All right? And the biggest angle is always across from the largest side, remember? If you're going to use law of sines, go with the smaller angle. All right? And so that's going to help you out not having those ambiguous cases. Okay? So if we're going to do this problem, which angle would I solve for first if I'm going to have to use law of cosines? B. Okay? So we're going to use angle B. So to set it up, I just use cosine of B is equal to my other two. And by my other two, I mean not the one across from it. So 8 squared plus 14 squared minus the one that works with B, so minus 19 squared over 2 times 8 times 14. Now, I personally wouldn't do this yet. How would I get to angle B? Arc cosine it. So we're going to arc cosine both sides. Now, when you put them in a calculator, make sure you put parentheses around the numerator and denominator. All right, so I get angle B is equal to 116.80 degrees. All right. Now, once we have that one, we could use law of cosines again. However, you don't need to. What could we use now? We could use law of sines. All right. So let's go ahead and solve for angle A using law of sines. All right. So I would have sine of A over what? 8 is equal to sine of over 19. And then I would multiply by 8, and then I would arc sine. All right, so then we're going to arc sine all of that.
I got a negative.
22.08 degrees. Now, one thing that I want to show you is this is actually if you use law of cosines to solve for angle A. Oh, this is law of sines. All right, so we end up with that. Now, once we have that angle, what do we get to use?
Subtract from 180.
We subtract them from 180. All right, so once we subtract them from 180, we end up with angle C is equal to 41.12 degrees. Very nice. All right, let's look at this triangle. So now I have sides of 9 and 12, and then an angle of 25. However, what is that angle? What do we say that angle is? It is included. All right, which means it's between those sides.
So that means you use a formula.
I can use a formula. Exactly. All right, now, can I use law of sines? No, nothing corresponds. Okay? 12 doesn't have angle C, 9 doesn't have angle B. Angle A doesn't have a side. So we have to use law of cosines again. And so let's put it in our formula. So now we have A squared is equal to my other two, so I have B squared plus not b squared. Let's fill it in. 9 squared plus 12 squared, right? Minus 2 times 9 times 12 times cosine of 25 degrees. Now, I wouldn't just do that part yet. What would I do? Let's square root it before you even put it in. All right, and if we put it in correctly, we get 5.4072 meters-ish. All right. Now, what can we use now? Law of sines. Now, this one is actually a hidden donkey. All right. So, which angle do I want to get with law of sines? Angle B. If I use angle C, it actually breaks. Okay. It actually becomes an ambiguous case, and it's not going to work. All right. So, law of sines, use the small one. Law of cosines, use the large one. Okay. So, let's use angle B here. All right, so now we have sine of b over 9, which is equal to sine of 25 over 5.4072. So then I multiply by 9, and then I arc sine it. So for angle B, I end up with 70 degrees. All right. So once we have that angle, we can subtract from 180 for both of them, and we end up with 110.30 degrees. Benny's going to be my women's softball player. Here we go.
Pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. How far is the pitcher's mound from first base?
All right, fantastic. All right. So I have an included angle of 45 degrees here. All right. I think on your homework you're going to have a baseball field. It's basically the same thing except for 90 feet bases. All right. So here we go. So I'd have h squared is equal to my other two sides, which are what? 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45 degrees. And before I put that in a calculator, I would square root both sides. After we enter it, we end up getting 42.4303-ish feet. All right. All right. Well,
Okay, to approximate the length of a march, a surveyor walks 250 meters from point A to point B, then turns 75 degrees and walks 220 meters to point C. Approximate the length A times C of the march.
AC of the marsh.
AC.
All right. Do you want 75 degrees? No. What do you actually want?
105.
We want 105 degrees because those are supplements. All right, so I use my formula. I enter everything in my calculator, and I end up with
307.
meters. All right. Worksheet 6.2a. Worksheet 6.2a. All right.